couple things here as it relates to iteration in Go. Go only uses the keyword for. All right. In fact, I'm going to come down here for a second, and I want to show you this. So if you notice, I'm constructing an array of 4 integers, and I'm using my literal construction syntax because it's not going to be set to its 0 value. And now what we're doing is we're initializing integers in every single element. Now, one of the things that Go does let you do, and I've never had a practical purpose for it, by the way. Why you'd want to do this, I don't know. But you can specify an index position here. If I saw that in code, it would probably stop a code review, okay? But Go lets you set up index positions for that. Another thing that Go will do is this type of syntax where it will look at the literal construction and determine what the value should be based on the construction there, okay? Again, when I see that, I tend to stop code reviews. But if you've got maybe tests where you're adding new stuff all the time and you don't want to go back and change the number, I think there's some value there. But overall, I don't see it being used a lot. And again, it would probably pause a code review initially. But from a syntax perspective, I want you to know those syntaxes exist, okay? And then Go has a traditional for loop. There's nothing special here. I'm going to imagine if you've been coding in other programming languages, you've seen this. One interesting thing about Go is that it does use the keyword for a while loop. That would be your while in Go. And these are built-in functions that Go has. You'll see a few of them as we go along. len, it's a function. It's built in. It's given to you by the language team. And so this is your while loop, right? Go didn't come up with different keywords. But something that Go took from some other languages is this for range loop. And it's a very powerful mechanic in Go. And I would argue that if the for range is the right mechanic, you should be using it over the traditional for. Now, one reason is because you can't go over the bounds of the iteration, right? So it's going to iterate from beginning to end. And you don't have to worry about, maybe messing this type of logic up. So that's nice. And there's 2 forms to this loop. This is the first form. And in this form, what you're doing is you're just saying, look, just give me an index position, and I'll access the collection directly. A lot of times you're going to do this when you need the data, that actual data itself from the collection. And really, I would say you're in a pointer semantic mode here, where you want to operate on the original data. This is the other form, and it's usually when you're operating in a value semantic way, where you want to operate on copies. Because this variable will be a copy of every element. So on the very first iteration, I will be 0, but fruit, and these are variables that are local to the for statement. Right? We're using short variable declaration operators. But this would be a copy. So if I came back to the board, what we would know here is that the fruit variable local to the for loop is a copy. We're operating in a value semantic mode. And again, when you're operating in value semantics, the idea is everybody should be operating on their own copy of the data. And this loop gives you the facility to maintain that data semantic consistency when value semantics should be at play. I'll come back to the code, Eric. I don't want to go deeper than that right now, other than to say this is your value semantic form of the for range. This is your pointer semantic form of the for range. And this is when you want to be operating on copies of the data. This is when you want to be operating on that original data for now. Okay, you can see that we're giving print its own copy of that string value on line 23. And normally when it comes to the built-in types, we're always going to be operating on our own copy of the data. So you'll see this type of syntax quite a bit in Go.